On account of its strong highlights, this would provide us with a much fuller picture of the world as we know it now. The most awesome picture ever seen was just taken by the James Webb Telescope. Join us as we dive deeper into the James Webb Telescope and how it could change everything, revealing how it all began. After the telescope was first proposed in 1996, 3 groups of scientists and engineers from the public and private sectors came together to see if NASA could actually build the telescope. All 3 groups reached the same conclusion: the telescope could be built. In 1997, NASA agreed to fund further studies to improve the technical and financial needs. By 2002, the organization had selected teams to build the telescope's most critical equipment and a scientific advisory group to assist with the building process. That same year, the telescope was officially named the James Webb Space Telescope, honoring the former NASA administrator who made significant contributions to the Apollo program. When engineers and scientists began constructing the Webb telescope in 2004, they had to develop new technologies and methods to meet the mission's strict scientific requirements. Unlike Hubble, which astronauts could repair and upgrade from Earth, Webb would have to perform its work from a location far beyond Earth's reach. Despite these challenges, the team completed all 18 mirror segments and subjected them to rigorous testing to ensure they met the necessary standards. Finally, it was possible to envision the telescope being launched into space and fulfilling its mission. The James Webb Space Telescope was built and tested between 2012 and 2013. Different parts of the telescope were being constructed in various locations worldwide. Construction on Webb's sunshield layers began in 2013. These layers protect the telescope from excessive heat, allowing it to function well in space. Over the following years, Webb's unique scientific instruments were put through extreme tests involving high temperatures and vibrations. Simultaneously, the telescope's 18 separate mirrors were carefully installed on its backplane. These components were assembled and tested at NASA's Johnson Space Center in Houston, Texas, in 2017. The telescope and its equipment also underwent one final round of environmental tests in a large thermal vacuum chamber to ensure they would operate correctly when launched into space. Webb was finally launched into space around Earth on December 25, 2021, at 7:20 a.m. Eastern Standard Time. ####how it works. So how does the telescope truly work? People often make space travel sound too easy, so when you first hear about it, it might seem like just another camera. That's not the case. It's entirely different, which is why it took so long to get from concept to launch day. The James Webb Telescope is a powerful telescope designed to observe objects in space that are too cold or faint for standard telescopes to see. These objects include stars, galaxies, and planets that are just beginning to form. The telescope is designed to capture infrared light, which is what these distant celestial bodies use to emit most of their heat. This allows us to learn more about these objects. Infrared light can't pass through gas and dust, which makes it look hazy to our eyes. Webb, however, can see bright radiation as well as visible light and infrared radiation. This allows it to take pictures of things hidden by dust and gas, giving us a clearer view of events happening far away in the universe. It's also possible to study the features of objects on Earth, like their chemical composition and temperature, using infrared light. Infrared light is useful in many areas of physics, science, and technology. It can help us explore how stars, galaxies, and other massive objects are formed and how they change over time. It can also be used to detect signs of chemical pollution in our environment. The telescope has a large collection of mirrors, advanced imaging and spectroscopy instruments, and cutting-edge thermal control systems that enable it to operate in harsh conditions like space, which, as you know, is extremely unforgiving. Because this camera is designed to operate in space independently, it had to be constructed to withstand any challenges it might encounter out there without assistance. ###after the launch. After the telescope was launched into space and separated from its launch vehicle, it unfolded and began its long journey to its destination, undergoing a complex series of steps along the way. There were several critical stages in this process, such as passing across the moon and breaking into different pieces. The telescope became one of the most powerful tools of its kind as soon as it was fully deployed. ###how it got to space. Let's take a look at the steps this groundbreaking telescope took to get into space before we discuss why it was so significant. The launch was the first crucial step. The solar array was deployed after the launch. On the third day of the journey, while the astronauts were still inside the spacecraft, the essential sun shields for Webb were stored in special cases. These sun shields keep the telescope cool, allowing it to function properly in space. The placement of these sun shields was vital to ensuring that the camera could operate effectively during its mission. On the fourth day, the tower holding the instrument package was moved to its final position and assembled. There were many complicated steps in this process, but everything went smoothly due to how the telescope was constructed. The speedfold was then raised. The sun's pressure acts on the large sun shield, creating a force that keeps the telescope stable. Next was the release of the sun shield layer cover, revealing the tennis court-sized sun shields. After everything was set up, the sun shield and mid-booms were deployed. The 5 layers of the sun shield were then separated. But this wasn't the end. When the James Webb Telescope was launched into space, it had to go through several crucial steps. The secondary mirror and a frame to hold the smaller mirror in place were deployed on day 10. The main mirror wings were then extended on day 13, giving the telescope its final shape. After these steps were completed, the telescope was ready to begin its job of observing distant stars and planets. What's the real purpose? What's fascinating about the James Webb Telescope is that it wasn't designed to do just one thing. It was built to address a wide range of scientific questions. Let's delve into this and explore some of its amazing capabilities. Peering into the past. Scientists like Daniel Einstein, an astronomer at the Harvard-Smithsonian Center for Astrophysics, can use telescopes like the James Webb Space Telescope to look back in time and see galaxies when they were just beginning to form. Light travels slowly, so a distant planet appears older than it actually is. The telescope can observe the early history of galaxies to learn more about how they formed and changed over time. Because it can see galaxies so far away, scientists like Einstein can get a complete picture of how galaxies form and evolve by observing them at different stages of development. Webb is perfect for studying distant galaxies because it can detect infrared light. The universe is expanding, which causes the light from these galaxies to stretch over time, changing its color from visible or ultraviolet to infrared. Webb excels at detecting infrared signals because it is large and cold, allowing it to see much farther into space than other telescopes. This makes it possible to observe galaxies as they grow and change, capturing images of their evolution over time. Through Webb, we can learn more about how galaxies form and evolve, helping us understand the universe better as a whole. Understanding stars. Scientists study stars from the specific point where they were born. Stars are formed from dense clouds of gas and dust known as stellar nurseries. These clouds are so dense that visible light cannot pass through them, making it difficult for scientists to study these areas using conventional optics. However, infrared light can penetrate the dusty clouds more easily than visible light. This allows scientists to see into the heart of these star nurseries in a way that other researchers cannot. Because the Webb telescope can see infrared light, scientists will be able to study these regions in much more detail than they could before. Maria, an infrared astronomer at the University of Arizona, is the principal investigator for one of Webb's cameras. She explains that red light has a longer wavelength and can pass through the dust in our atmosphere better than blue light. Additionally, infrared light can penetrate deeper into dusty galaxies than visible light. Due to this effect, the sun appears redder at sunset than during the day. At the same time, because it can detect infrared light more effectively, Webb will allow researchers to study the formation of stars beneath the surface, something Hubble could only do to a limited extent. Webb's broader range of infrared bands will enable scientists to see deeper into the dust and learn more about how stars are born and grow. Studying black holes. Black holes are challenging to observe because they can trap light, making them some of the most mysterious objects in the universe. However, we can observe how black holes affect the stars and galaxies around them. Scientists have studied various aspects of black holes using telescopes like X-ray telescopes. For example, they have examined how the intense destruction of nearby stars creates a hot, energetic region near black holes. With the launch of NASA's Webb telescope, Its infrared instruments will allow scientists to learn more about black holes. They can gain new insights into the complex physics occurring near black holes by observing the cooler gases and stars swirling around them. Scientists are still studying black holes, even though they are not directly visible. They will continue to be a significant area of research in the future. When you look at stars in dense, dusty regions of space, it can be difficult to study them, which is why we need telescopes like Webb. These challenges cannot be overcome by optical telescopes like the Hubble Space Telescope. The exciting thing about Webb is that it can detect the light emitted by stars, even through dust clouds. This means that scientists can use the telescope to observe parts of space that are currently hidden from view. The James Webb Space Telescope can detect and study the light from stars obscured by gas and dust, unlike Hubble, which could only observe galaxies at specific wavelengths. Webb can observe objects at various wavelengths, allowing researchers to study regions that are otherwise difficult to see with visible light. In addition to investigating areas that are not directly visible, the Webb telescope will also search for signs of light emission from materials falling into black holes. Unlike optical telescopes like Hubble, the Webb telescope will observe the invisible universe in infrared, capturing high-resolution images of objects hidden behind clouds of dust. This will allow scientists to observe objects in deep space, such as stars and galaxies, even when blocked by gas and dust. Webb will reveal hidden features of our universe and enhance our understanding of black holes. The Webb telescope will improve our understanding of the universe and allow us to explore things hidden from view. The incredible images Webb captures will help scientists better understand the complex processes occurring in the universe. #### Formation of planets and galaxies. The Webb telescope has many other purposes. It can be used to study the formation of planets, stars, and galaxies. The telescope will take pictures of newly formed planets and galaxies to observe how they interact with each other. This will help scientists understand the birth and evolution of galaxies over time. The Webb telescope will provide information about how these systems formed and evolved and what conditions were present during their early stages. By studying these processes, scientists will be able to understand better how our universe came into being and how it has changed since its formation. The Webb telescope will also investigate the early universe, looking back in time to learn more about how our universe formed. Webb's primary mission is to observe the formation of stars, planets, and galaxies at different stages of development. By doing this, scientists will gain new insights into the processes that shape our universe and the conditions present during these early stages. This will help us better understand our universe and the factors contributing to its formation and evolution. ### Discovery of exoplanets. The James Webb Space Telescope is also designed to study exoplanets. Exoplanets are planets that orbit stars other than our Sun. They can be gas giants like Jupiter or rocky planets like Earth. Many of these exoplanets are located in the habitable zone of their stars, meaning they could have conditions that allow liquid water to exist on their surfaces. One of the main goals of the Webb telescope is to search for signs of life on these exoplanets by analyzing their atmospheres. Webb's infrared instruments will be able to detect the presence of molecules such as water, carbon dioxide, and methane in the atmospheres of exoplanets. By studying these molecules, scientists will learn more about the potential habitability of these distant worlds. The telescope will also be able to detect the presence of clouds, weather patterns, and other atmospheric phenomena on exoplanets, providing a more detailed understanding of their environments. Webb's ability to study exoplanets in detail will help scientists identify planets that may have conditions suitable for life. This could lead to the discovery of new Earth-like planets and increase our understanding of the diversity of planetary systems in our galaxy. ### Challenges and future exploration. The James Webb Space Telescope has overcome numerous challenges to reach its current state. Building and launching such a complex instrument required extensive collaboration between scientists, engineers, and organizations worldwide. The telescope's success is a testament to human ingenuity and the pursuit of knowledge. As Webb continues its mission, it will undoubtedly make groundbreaking discoveries that will reshape our understanding of the universe. From studying the formation of stars and galaxies to searching for signs of life on exoplanets, the James Webb Space Telescope will significantly impact the field of astronomy and beyond. Its observations will provide valuable data that will guide future space exploration and scientific research for years.